Okay, welcome back. So now I'm going to do problems 3 and 4. If you look at number 3 here, the information that I gave you was just the first and second derivative, which we would have been able to find with that. But just kind of some, like we did on 1 and 2, sometimes we give you a little bit of information. So using this first derivative, I'm going to find those critical values. I will set this equal to 0 and solve. So we end up getting critical values at plus or minus square root of 3. This 3 here doesn't do anything because it doesn't have an x. So let's make our number line and start testing these intervals to see where the graph is increasing or decreasing. And then this will help us determine if we have any max or mins. So looking at this, if I pick a value over here, I'll say x is -2. A value between here, I'll say x is 0, and then x is 2. Okay, so plugging in and up here, if I plug in -2 here, this becomes positive. Positive and positive make a positive. So this is where the graph is increasing. If I plug in 0 for x to the first derivative, you end up getting a negative here. Positive times a negative is a negative. So in this interval, the graph is decreasing. And if I plug in 2 here, I end up getting positive 1 times 3, that's positive. So that's where the graph is increasing. So looking at this, I know I have a max value at -√3, and I know I have a minimum value at √3, because this is where the graph is increasing and then decreases. That means we have a max. This is where it's decreasing and then starts to increase. That's where we have a minimum. So we'll need to find these ordered pairs. So I'll need to find the y value for this and the y value for this. So we'll do this after we look at the point of inflection. So looking at this, if I set this equal to 0, I end up getting x equals 0. So I need to test if this is a POI. So I pick a value to the left, pick a value to the right. So plugging this back into the second derivative, if I plug in -1, that's negative. If I plug in +1, that gives me a positive value. And this talks about concavity. So in this interval, concavity is is down, and then it concaves up when it's greater than 0. Okay, so this is a POI, so I need to have that point on the graph. So I use my x value of 0. Okay, to find these y values, we go back to the original function because that's what we're graphing. So I'm going to plug in -√3. Okay, so with this, since we're graphing, I'm fine with us getting a decimal here, so we can use our calculator and type this in and piece it together. We end up getting 12.4. We're going to do the same thing with √3. Again, I'm okay since we're graphing with us getting a decimal and just rounding to the tenths. You should get -8.4. And then we can plug in 0. Again, all to the original, and that comes out a nice, pretty 2. Okay, so let's look at this. We're ready to start graphing. I am going to, oops. Okay, hang on. Okay, so let me put these points on the graph. So -√3. I'm going to say is about up here. So remember, every point we label what it is and what the point is. So that's a max. And then I'm going to graph this √3, -8.4, and that is a min. And then 0.2 is about right here, and that's a POI. Okie doke. So then I go put my dashed lines in after I graph those points. and I'm going to see what is happening in every interval. Are we increasing? Are we decreasing? What's the concavity look like? So let's talk about increasing and decreasing. So from negative infinity to root 3, we are increasing. We can see that right here. Then from negative root 3 to positive root 3, so over both these sections, we are decreasing. Then from root 3 to infinity, we can see that we are increasing. Concavity, it is concave down when you're to the left of 0. So these are both CC down. And then when you're to the right, it's concave up. So we put this underneath. Okay, so I'm going to start over here. So if I'm increasing, which makes sense, I need to get to that max value. And we're concave down, so it's like so. Then it makes sense that I'm decreasing to get to this point, and we're still concave down. Then it makes sense that I'm decreasing to get from this point to this point, but now I'm switching concavity. And then from this point, we're going up, and we're still concaving up. So there is our curve sketch for number 3. Okay. Moving on to number 4. So with number 4, now we have an example of that we're going to do one start to finish. So here we go. We follow these same steps of we got to find the first derivative and the second derivative to find those max and mins and POI. So let's start with the first derivative. So we find our first derivative. I'm going to set this equal to 0, and I'm going to go ahead and take out that 3 so that we can find our critical values. So when I do this, we factor it like so, set both of those equal to 0, and these are my critical values. So this means I could potentially have a max or min here. It doesn't mean definite, but we could. Okay, so I put these on a number line, and I'm going to test some values. So I'm just going to pick some values. Oops. Well, I guess I could do -3, x equals 0, and then I'll say x equals 4. I'm testing it in my first derivative. So when I plug in -3 here, that turns negative. That's also negative. Negative times negative is a positive. So in that part of the graph, it's increasing. When I plug in 0, this factor is negative and this is positive. So negative and positive give us a negative. So in this interval, it's decreasing. When I plug in 4, everything's positive. So all multiplied together will be positive. So on that interval, it is increasing. So looking at increasing and decreasing, I'm increasing and then I decrease. So that's a max. I'm decreasing, then I increase. So that's a min. So I know I have a max at -1. I'll find my y value. I have a minimum at 3, and I'll find my y value. Okay, we now go do the second derivative because I have to see if we change concavity here, if there's any point of inflection. So using my first derivative, I'm going to take the derivative of that. And then I'm going to set that equal to 0 and factor. So I factored out a 6. I set that equal to 0. I have a potential point of inflection at 1. So I'm testing numbers to either side. So I just pick some x values on either side, and I'm plugging it in anywhere. So if I plug in a 0 here, that's -1 times +6 gives us a negative. So we are concave down at that point. If I plug in a 2, it's positive and positive, so that gives us a positive, meaning we're concave up in this interval. So that is a point of inflection because it changes concavity. So we have a point of inflection at 1. We got to find the y value. Okay, so these are the points I'm going to graph. I go back to my original function and I plug in these x values in there. So first plug in -1. Sorry about that. Okay, so when I plug in -1, I end up getting +5. I I'm then going to plug in 3 to the original function. And when I evaluate that, I get negative 27. And then I'm going to plug in positive 1. And I get negative 11. So I'm going to graph these 3 points on my graph. Okay, so here we go. Okay, so negative 1, 5, I have a max value, so I label it. At 3, negative 27, I have a min. And then at 1, negative 11, I have a POI. Okay, so we're labeling everything. I'm then going to put my dash lines in so I can look at over every interval, am I increasing or am I decreasing? And then what's my concavity look like? Okay, so scrolling back up here, we can see that I'm increasing until negative 1. So this first interval, I am increasing. And then from negative 1 to 3, which is both of these, I am decreasing. And then from positive 3 to infinity, I am increasing. Looking at concavity, you change from concave down to concave up at positive 1. So to the left of positive 1, I am concave down. So that's going to be here and here. But then once I hit positive 1, it's concave up. Okay, so looking at this first one, I need to increase and I need to concave down. So I need to be approaching that max like so, and it needs to be concave down. I am going to be decreasing from this point to this point, and I'm still concave down like so. I am going to continue to decrease, which makes sense because I got to get to this point, but now I am concave up. And then in this interval, I'm increasing and I'm still concave up. So there's our curve sketch for that. Okay, great job, guys. So now you need to go do that last problem on your assignment and check with the solutions on the back.